I'd like to do a little exercise with you. I'd like you to remember a few sets of numbers. So I'm just going to do like three numbers. The first one is 724. 724. The next one is 319. And the last one is 126. So those three numbers again, I'd like you to just keep in your mind are 724, 319, 126. Now, for many people, memorizing or remembering lots of things takes overhead. It takes mental energy. And the same thing for a router. If a router is getting LSAs, the link state advertisements about other routers, like if you and I are router 1 and we're getting updates from router 2 and router 2 saying, oh yeah, I've got these 4 interfaces with these 4 networks and here's the cost for those individual interfaces. If we have to remember all that, if we have hundreds or thousands of routers, that doesn't scale very well because then we have a router like ourselves that has to have all those LSAs remembered and put into our link state database. So to solve that problem, OSPF can be taken as a whole and it can be put into separate domains or chunks. So I'd like to describe this concept with you in this nugget to give you the concept of an area, why it's beneficial, and then once we understand the bigger picture, we're then going to return to focusing on a single area OSPF network as we continue to configure it, verify it, and when required, troubleshoot it. So to reinforce that concept, let's go ahead and put some routers here. So we got these routers and these routers, and we'll do one more layer. All right, like stacking cannonballs or something. All right, so all of these are unique routers, and with LSAs, link state advertisements, let's imagine that every router has at least 4 interfaces or more that are currently up and they're connected to IP networks. That means that every router is sending advertisements about, hey, here's my 4 interfaces, and here's their status, and here's their state, and here's the IP networks that they're connected to. And if I'm a router down here, 1, 2, 3, I'll label these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Great. So if I'm router 9, I'm effectively going to get the information from router 1, router 2, router 3, everybody else. We're getting all their interfaces and all their connections and all their networks, and that's a lot to keep track of in my link state database. So if these are all in a single area in OSPF, that's what would happen. Every router would have information about the link state advertisements from every other router in the network, and it could be a lot of overhead. So one option with larger networks with OSPF is we can divide our OSPF routers into subsections or domains or groupings. And it might look something like this. So this could be called area, and we could call it 0.0.0.0. Also, that's often called area 0 just by itself. It's just a number, a label, if you will, for an area, a grouping of networks that are in a certain area. And routers really don't belong to an area. It's really their networks they're connected to. So if this was area 0, these 4 interfaces could belong to area 0. Maybe these 3 interfaces in R2 belong to area 0. So when we think of areas, think of collections of networks as opposed to a single router, because we could have a situation like this where we have another area. Let's take this area right here. And perhaps router 2 has a connection right here. So and let's call this area 1. In this case, router 2 might have a connection or an interface that's part of area 1. I'll put that in red here as well. And so the point here is that when we think about areas or groupings of networks, it's just that. It's not this router belongs just to this one area. It'd be more accurate to say for router 1 that all of its interfaces, all of its networks belong to area 0. Or router 3's, all of its interfaces belong to area 0. And R2, only 3 interfaces. Those 3 networks belong to area 0, and one of these interfaces belongs to area 1. And we could further divide or group our networks, and maybe we call this area 2. And then this router here, router 3, could have a connection that goes into area 2 for routing purposes. And the benefit here is that when this router, router 1, is advertising LSAs, his LSA does not have to make it through the entire network. His LSA can stay in the area, and then we can have R2 advertise the fact that, hey, if you need to get somewhere else, use me. But the bottom line is, by chunking this up into areas, we don't have to have every single router have personal knowledge of the LSAs from every single other network and every other single router in the entire OSPF infrastructure. So that's the concept of breaking up OSPF into smaller areas so that we are decreasing the workload on each of the routers, which are trying to calculate the shortest path to any given destination network. So in the case of R9 here, instead of having to know all the details about everything up here in area 0, it would simply know, hey, I've got this bad boy, router 5, that's acting as a gateway or a route, if you will, that can forward packets to anywhere outside of my local area. And at the same time, router 9, his workload's been released because he no longer has to process or keep track of the link states being advertised by router 3 or router 1. And the reason I wanted to introduce this concept of breaking it into areas, even though in this nugget, in this skill, we're going to focus on area 0, was that when we start telling a router, hey, this network and that network and this network, add them to OSPF, we need to also tell it which area we're going to add those networks to. So for our discussion going forward, we're going to add all of our interfaces, all of our directly connected networks into area 0. And then later, when we're taking a look at advanced topics and things like CCNP and CCIE, we'll take a look at multi-area OSPF and how to make that work as well. But for you and I today, we're starting here with single area OSPF to understand how it works, how to verify it, and how to troubleshoot it. And I look forward to seeing you in a few moments in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.